Let's now develop comprehensive testing for a deque implementation. So what we are going to do is with a large set of data, we just apply randomly the operations of push front, push back, or pop front, pop back, and then compare the result. So to do so, let's learn how to generate the numbers randomly. And C++ has a random library. So let's include the random library. And then let me show you how to generate random numbers. So here what we are going to do is comprehensive testing. So random number is we need to first have a random number generator. From the random library, we have a default random engine. Then let's name it as a gen object. So this gen object will generate random numbers. And then what kind of a random number we need is we need the uniform int distribution, integer, and then let's call it distribution. Here you specify the integer number ranges that you want to generate randomly. For this testing, let's generate random numbers 1 through 6 inclusively. And then let's test how this works. So for int I, 0, I is, for example, 100. And then generate the random numbers. That is using distribution defined. Give the generator engine. Let me give one blank there. Cout is in error because IO stream is not included. There. Then let's test this part. Okay. Compile and run. So these are the random numbers, 1 through 6. So if I run this again, what interesting thing is that I get exactly the same sequence again and again as I run exactly the same sequence. So that is because the random number is generated based on some seed. So we want to perfectly randomize that. Then we just give as a seed of the random number generation from the current time. So that's time function, give 0 is there. And time function is defined in ctime library. Ctime library. So by giving random number generation seed randomly based on the current time, then we can have random numbers. Every time we run again, this is the number, and this is the number. So the random number is generated across the program execution now. So that's the random number generation part. And then let me comment that part. And then another one is that I want to randomly apply 4 functions, 2 push and 2 pops. But I want to give more push, adding the data into the deque, than pop, removing the data. So out of 1 through 6, so 1 and 2 is to push, another 3 and 4 is another push operation, but remaining 5 and 6 is for pop operation and the like. I want to apply that way. And then as we store data into the deque, I need to know what is the end result. So to do so, I'm going to use a vector object, vector class from the library. I want to give a integer. So vector is a flexible array, so you can store int type as if an array, but the size is not limited. And the vector is defined in vector library. So from the library, I'm going to use a vector. So the plan is as follows. As I store data into the deque, I also store data into the vector accordingly. And then after testing with a large set of data randomly generated, and then randomly chosen functions, then I want to compare the end result with the vector, whether they are same or not. So let's define now deque object called the test, and then assert that test length is 0 at the very beginning. Now what I want to do is using a loop, large set of data n, and then I want to do something. So here let's define const int n is some large number as you like. Then what I want to do is let's generate random number 1 through 6, switch distribution gen, then 1 through 6 is generated. Then if 1 or 2 is there, then I want to do push front operation I want to do. And then if I have 3 or 4, I want to push back function. And then if case is 5, I want to do pop front, remove the data. And then case 6, pop back. Do that. Then we do that operations concurrently on a vector as well as a deque, and then the end result we are going to compare that. So push front, so test is a deque, and then we have a push front function, and then give the number I is 0 through n minus 1, so we do that, and then we need to push the data at the very beginning index at index 0. We need to insert the I into index 0 of the vector, but in the vector it does not have such operation. So what we need to do is we need to find how to insert the data. Here is a vector, C++ vector. If you search that, then the first hit is the explanation of how to use a vector class. And the vector has a insert function. And to use insert function, you need to specify where you want to insert the data. So where that information comes from the iterator, the very beginning, as you get the iterator from the vector, that is the first position of the vector, and then you can insert that. For the details, we may have opportunity to study the C++ standard library later. So this is one of the C++ standard library, but what we need is as follows. So let's define a function, void insert. It's a push front and vector. So I'm going to design a function for that. Vector int type, reference is there, and then data is there. So what we need to do is first we need to get an iterator, which is a vector int colon. Inner class is iterator. Let's name it as it is from v, and then begin function call, we return the iterator, and it's pointing to the very first element. And then I can call insert the function at this iterator location and data. So this is how to insert data into the vector at the very first index, at index 0, and all the data, existing data, will be shifted to open the position there. So we do push front on the deque, and then we call push front vector, pass the vector, and then pass the data there. So for this vector, we insert I. and then push it back. And deque test we have a push back function there. And then for the vector, we have a push back function as well. From the standard library, we can simply call that. And then pop front test pop front we remove, and then pop front in the vector we don't have such function in the vector standard library, so we need to define pop front vector, pass the vector, and then let's define it. Void pop front from vector, the vector into type v reference v, and in there. Then also we need a iterator. Begin is the very first one, and then from v we call erase a function with a iterator there. Then the very first element is removed. Then pop back test dot pop back, and the vector has a pop back as well, so we can remove that. So we have a 6,000 data, and then randomly just to do push and the pop is there. So one thing we need to assert is that if there's no data, we cannot pop at all. So make sure that if test length is 0, then don't do any operation for pop. So just validate the condition there. So once we have all done, this is the end of the loop. Then let's see what is the length of the queue is there. So let's test up to here. Make push front pop front undefined because I use that before it's defined. So I need to give a prototype. So let me copy this line and then give it here like this prototype. We do not need to give a parameter name there, and then also pop front vector. Let's give a prototype of the function and compile again, then run it. So out of 6,000 data, at the end of the testing through push and pop, the remaining data is about 2,000. That makes sense. Here, what we do is 4 out of 6, so we add, and then 2 out of 6, so we remove. So overall, 1/3 will be left over. 2/3 are added, 1/3 are removed, so remaining should be 1/3. So out of 6,000, 1/3 is about 2,000. So that's a leftover. Run again. So leftover changes because we do randomly those choice of functions. So now we need to verify the data. Compare v with the test. Test is deque, v is a vector. So let's compare one by one. Vectors is size, the function is how many elements are in the vector. So using the vector, so assert that test front is the very first data. So vector has, you can use index notation like as if an array. So when I is 0, it's a front there. And then from the deque, we pop front, the very first element, we remove that. And then if we keep looping that, I is incremented, and then from the deque we remove from the front. So always the front and the v index I should be the same. That's testing. So let's compile again, run again, and then this assertion satisfies. Then we have done randomized comprehensive testing for deque.